Hello everyone, welcome to Mosaic 3D. Today we are introducing to you about how to prepare a proper model for simulation. So first we have to introduce to you we have two different kind of programs. The blue one, which we call designer, is prepared for the mesh file for simulation. And the red one, we call it project to do the pre-process and post-process of the simulation in there. So today we are gonna introduce to you about the designer first. So when you get into the designer, there will be a dialog pop out, which will ask you about which method you want to use, the eDesign or the boundary layer mesh mode. And today we are going to introduce to you about eDesign. So we will select eDesign mode and click on OK. So as soon as you get into the interface, you can see the numbers at the left side in here. So you can see like 1 to 5, and if you follow these 5 numbers, you can get a proper mesh ready for the simulation. So let's get started. So first, we will import a geometry. And for importing the geometry, we have a different variety of CAD files accepted, like STL file, IGS file, or step file. So today we are going to use the STL file. Okay. So as soon as you import a file, you can see that we need to assign the unit for the file. And usually we will use the millimeters as the standard unit. Okay. So this is the part that we are going to do the demo. And here you can see few functions. The first one is the check surface mesh. The check surface mesh is make sure the model is proper for the model prepare. So if there's any defect, please make sure you export another new file from your CAD software. So your simulation can be done smoothly. And the next one you can use is display model thickness. So use the display model thickness, you can have a brief idea about how the thickness distribute in your part. Maybe, for example, you would like to leave the gate in the thicker wall region. So maybe we will leave the gate in here. And also you can see if there is any position will cause the heat accumulation or where to put the cooling channel. Via the display model thickness, you have more idea about how the thickness distribute in your part. Okay, so let's get to the next step. The next step is building the runner system. The first one is assigning the gate location. So click on the gate wizard, and then we can assign the gate at the position that we want. And also in here, you can adjust the diameter of the gate. The red point is the diameter, which is close to the part. So we put it like 1.2. So you can see the diameter is changed, and also we can change this to 4. Okay, so the gate is ready, and click yes, and then go on to the next gate if you have any, and then we want to assign another gate in here. Okay, so after it's done, the gate is ready, and for the next step, you can assign the runner. So with the runner wizard, you can easily generate a runner like this. Simple one click and the runner is ready. If you have like one gate, will generate one gate runner. If you have two gates, will generate a corresponding number of the gate, a corresponding runner to the gate number. And also you can adjust the parameters of the runner in here. So for example, this is the distance between the gate and this cross section. So we put it 30 and it becomes higher. Okay, so the runner is ready. So in the built-in runner system, you always can use the gate wizard to assign the gate location. And also for the runner, we can import curves or import a geometry if you have any like designed runner. And after that, you need to assign the melt entrance by yourself, because if you are using the runner wizard, we will assign this one, which is the melt entrance, by us. But if you are importing the geometry by yourself, you need to assign the melt entrance by yourself. Okay, let's go on to the next step, which is the stack cooling channel system. When it comes to the cooling channel system, there's two items. The first one is the mode base, and the second one is the cooling channel. So we will use the mode base wizard first. So in here, you can see that with the mode base wizard, we will generate the mode base automatically, and you can always change the parameters in here, like the length and width of the mode base, and also the height of the mode base. Okay, and when it's done, you can assign use the cooling channel wizard to generate the cooling channel. So simple one click, we will generate a cooling channel for you. And in here, we have different parameters for you to adjust. For example, this is the diameter of the cooling channel. And if we change it to 6, the cooling channel diameter will be changed to 6. And you can also change the number of your cooling channel. For example, we change it to 4, and it will be 4 at each side, upper side and the lower side. And also the C is the distance between the cavity and the cooling channel. So you can see in here. The C is the distance between each cooling channel. So you can see the number is adjusting in here. And the edge is the distance between the cavity and the cooling channel. And here we can connect each cooling channel together if you want. So you can use host to connect it or either use channel to connect it. And also you can adjust the position of like you can choose to show only in core side or cavity side, like this. Okay, when it's done, you can simply click yes. And then you can assign the inlet, you have to assign the inlet and outlet of the cooling channel using the wizard. So with simple one click, the inlet and outlet is assigned. And the last step is to check the cooling channel. Of course, we always support you to like import your own mode base or your own cooling channel. And in here, we all have the functions. So the last step, after we checking, we can see that the result of check is okay. So that means the model is totally ready for simulation. So the number 4 step is to generate the mesh. So with generate mesh, you simply click on generate. And then here we have the accuracy level. The level 5 is more accurate, but it will take more time. So if you want to have more accurate simulation, maybe you can use level 5, but if you want to do a fast iteration, maybe you can use level 3 or level 2 to do the like some brief idea about how the injection molding will go. And then after you select the accuracy level and then click yes, and the mesh will be generated automatically. So when it comes to generating the mesh, it's really simple. You simply follow from step 1 to 4 and then click on each item that you need. Then the mesh is done. So we can see that the mesh is ready for the simulation. Now, the last step is to export it as the mesh file that our project accepted. So you click on the save mesh file and then save it as the MDE file, which is for the eDesign project. Okay, let's save it, and after a while, it will take some time, but after a while, it will be done. And this is how to prepare a model in eDesign, especially in Designer, so the model will be ready for your simulation.